Hello, I'm Kwon Yoon, a professor at Hanshin University. Today, we are going to think about data workforce and capabilities. It is the third module of the data-based government course, which will be the second time to learn key issues in data-based government. This lecture explores the data competency and manpower required for data-based government. For data-based digital transformation in the operation of government organizations, the data competency of organizational members is required. Recruitment of data personnel and data education for internal members are highlighted for data competency. In this module, we aim to achieve 4 goals. The first is to understand the concepts of data people and capabilities. The second is to understand the challenges of today's data capabilities. The third is to understand examples of government data capabilities. The fourth is to understand the issues and key factors for improving data capabilities. The content of the class consists of 3 main parts: background, cases, issues, and key factors. Data capability refers to the ability to best perform data functions. The classification of data features varies, but basically includes the following features: data planning, collection, analysis, utilization, expression, management. Data capability can span multiple dimensions, such as organizational dimension, human dimension, infrastructural dimension. At the organizational dimension, data competencies include various organizational variables, such as planning, departments, leader, collaboration, culture, budget, and so on. In the human dimension, personal data skills or professional manpower are important for data capability. So, education or human resource recruitment is emphasized to secure it. Data capability at the infrastructural level includes infrastructural elements that support the operation of organizations or people, such as technology, legislation, etc. The narrow definition of data capability focuses mainly on the human dimension, such as data analysis capability or individual skill in the human level. On the other hand, a broad definition would involve competencies at the organizational level or the foundation level. When it comes to data workforce, the size of the global digital data market continues to grow, and currently the size of the workforce working there is also growing year after year. The size of the global digital data market, including the EU, Japan, Brazil, and the United States, increased from $278 billion in 2017 to $424 billion in 2021. And the workforce increased from 25.7 million people to 29.3 million people. The workforce could not keep up with the increase in market size. Looking at the EU data in more detail, the proportion or increase rate of the professional service sector is high among various fields. In the case of Korea, although the size of the data industry manpower is small compared to the previous four countries, it can be confirmed that it is also continuously increasing. The steep increase in web searches, including the terms data science and data scientist, obtained through Google Trends tool, differently from more traditional disciplines of science, the boundaries of data science have not been formally clarified from an academic point of view. Despite of the discipline development, there is a natural tendency for people to confuse the definition of the field with the description of what data scientists do. Tuffield et al. 2015 investigated 326 peer-reviewed journal articles on big data that have explicitly addressed big data challenges that might hinder the government organization from exploiting open and big data to transform the government for enhanced public services and increased citizen engagement. They identified four categories of organizational capability challenges: socio-political capability challenges, strategic change capability challenges, analytical capability challenges, technical capability challenges. Analytical competence challenges appear the most frequently. In order for the government to realize DBG, manpower with high data capability is needed. Many countries are struggling to secure a workforce with high data competencies. The U.S. OPM is the department responsible for human resource management in the federal government in the U.S. The department has prepared a strategy plan for the next 5 years, starting in 2022. Among them, the emphasis on data-based problem solving stands out. OPM has the Data Analysis Group, DAG, as its division. The DAG analyzes data from a variety of data sources, including the Enterprise Human Resources Integration Statistical Data Mart, EHRI-SDM. It provides data and analysis results to internal administration, as well as to the President and Congress. Other public and media institutions and educational institutions. The EHRI-SDM includes a variety of information, including occupations, affiliations, salaries, promotions, awards, and transactions of 2 million federal civil servants. The AGs use this data to analyze changes or trends in personnel policies or laws. In the UK, civil service personnel management is mainly handled by the Civil Service or CS, and Civil Service Commission or CSC is involved in regulating the recruitment of the CS. CSC or CS emphasizes data competencies or digital competencies. First of all, CSC includes digital technology skills, presenting skill diversity as one of its strategic priorities in its strategic framework from 2016 to 2020. And it is employing data analysis as an important means to implement these strategies. The Australian Public Service Commission, or APSC, delivered the APS Workforce Strategy 2025 to the government in 2021. The strategy has set a key goal to enable the Australian civil service workforce to maximize data, technology, and digital engagement. And the action plan to achieve this includes embracing data and technology. More specifically, the action plan includes the development of core digital and data literacy skills and a strategy for digital and data professionals. And embracing data and technology includes supporting the planning of digital transformation programs or understanding the requirements of the entire civil service data infrastructure. As such, the government needs competent data manpower for a data-based government. From now on, let's take a look at the issues and key factors of data manpower and capabilities necessary for the success of data-based government. In this lecture, we are going to examine 4 things: data manpower shortages, data education and training, classification of data jobs and skills, and merging data skills into other skills. First, let's address the problem of data manpower shortage. In this field, the biggest problem is the lack of manpower to support the data-based government and data economy. Despite the fame of big data, its potential is far from being fully realized. According to survey data, 85% of organizations plan to use big data, but only 17% believe they have adequate capabilities to make full use of the technology. This has provided an advantage of data-driven companies that have been early adopters. Another study found that the companies that have embraced big data are 4% more productive than their peers and have 6% higher profitability. Despite the disagreement on workforce impact as a result of AI, there is consensus across the surveys that the companies making investments in AI are facing significant challenges in recruiting employees with the required AI skills. In a recent report by a national job search firm, data indicates that the shortage is getting worse. While more job seekers are interested in data science jobs, the number of job postings from employees has been rising faster than the number of interested applicants. With the New York region experiencing the biggest gap in talent. LinkedIn calculates that in August 2018, employers nationwide were seeking 151,717 more data scientists than exist in the United States. According to the Korea Data Agency 2021, within the next 5 years, the average manpower shortage for data jobs in all industries, including general industries, was 10.7%, and the data scientist shortage rate was the highest at 30.3%. Data education and training is the most important factor to solve the problem of data manpower shortage. As a framework for data education and training, Microsoft's TDSP is a good reference. The Team Data Science Process, TDSP, is a framework developed by Microsoft that provides a structured methodology to build predictive analytics solutions and intelligent applicants efficiently. There are 5 lifecycle stages in the TDSP: business understanding, data acquisition and understanding, modeling, deployment, and customer acceptance. An important feature of TDSP is that it is a structure in which business, data modeling, and service are interconnected in a team unit. The TDSP is composed of data science groups and data science teams within groups. In such a structure, there will be group and team leads. Typically, a data science project is done by a data science team, which may be composed of project leads and data scientists or engineers who will execute the data science and data engineering parts of the project. Prior to execution, the setup and governance is done by the group, team, or project leads. There are 4 distinct roles for team personnel: group manager, team lead, project lead, and project individual contributor. Group manager is the manager of the entire data science unit in an enterprise. A data science unit might have multiple teams, each of which is working on multiple data science projects in distinct business verticals. A group manager might delegate their tasks to a surrogate, but the tasks associated with the role do not change. A team lead is managing a team in the data science unit of an enterprise. A team consists of multiple data scientists. A project lead manages the daily activities of the individual data scientists on a specific data science project. Project individual contributor are data scientist, a business analyst, data engineer, architect, etc. A project individual contributor executes a data science project. The NJ Big Data Alliance presented the New Jersey Big Data Workforce Roadmap in 2019. This is a data science education and training roadmap created on the premise that maintaining computing and analysis skills throughout life is a prerequisite in the transition to a data-driven economy. This is largely divided into 3 stages of pre-career, career, post-career, and is divided into 6 stages in detail. That is, the pre-career stage consists of a K-12 stage and college stage again, and the career stage consists of 3 stages: entry level, middle level, and advanced career. It provides the role of skill sets in demand, individual, educator, employer as each stage. The NJ Big Data Alliance emphasizes a collaboration between industry and academia in the application of actual education and training. Microsoft TDSP at a micro level, New Jersey Big Data Workforce Roadmap at a more macro level can be a reference for data training program design. However, as this is a fairly ideal structure, there may be limitations in directly applying it to the government right now. Recently in Korea, education and training programs to strengthen data competency have been activated after the passage of the Database Administration Act. Among these, examples of designs designed as online courses are as follows. This course is divided into a literature course and practical course. The former focuses on data-based scientific management, and the latter focuses on the basic knowledge required for data use and collaboration and data mindset formation through this. The data literacy course consists of 5 sessions such as data-based administrative law, jointly used data, public big data and overseas cases, public big data analysis and use cases, and the role of a leader in the data-based administration. The data mind course consists of 5 lessons such as the importance of data, data-based administration, data utilization planning, practical knowledge for data analysis, and public big data analysis use cases. When it comes to categorizing data jobs and skills in the government, the UK example can help. The UKCS presented Digital Data Technology (DDAT) Profession Capability Framework in 2017. As part of the UK government's digital transformation strategy in 2017, the role and skills required for digital jobs in the government are presented. In this framework, 5 job families and various sub-positions are suggested. Data, IT operations, product and delivery, quality management, technology, user-centered design. You will find that the data job family includes data analysts, data engineers, data scientists, and performance analysts. It is significant that performance analysts are included in the data profession. This means that data work in an organization is deeply connected with planning or evaluation. Overall, data-driven government in the UK is being done as part of a digital strategy, which helps to understand where data capabilities are located. Data skills are linked to digital skills, but non-technical skills needed to be integrated and added to data skills for them to actually work and ultimately lead to effective problem solving or efficient service delivery. Sheffield et al. 2015 accurately points out this. They first note that data skills of employees are important in organizations. Manica et al. 2011 argues that there is a substantial shortage of manpower with such skills in practice, but nonetheless, suggests that the opinion of Hotgrave 2014 that the lack of non-technical skills may add greater obstacles and challenges. Examples of non-technical skills they provide include English, project management, organizational skills, and communication skills. Finally, we'll close with a summary. As data economy develops, the demand for data manpower is increasing. In cases such as the United States, United Kingdom, and Australia, we can see that the government is in need of personnel with data expertise. The demand for data manpower is increasing, but the supply of data manpower is not adequate to meet this demand. The government should encourage public officials to have data expertise, and to this end, data education and training should be strengthened. Microsoft TDSP at a micro level, New Jersey Big Data Workforce Roadmap at a more macro level can be an ideal reference for data education and training program design. In Korea, data education and training programs for government officials, including leadership and practical courses, can be a realistic reference. One of the key points in data education and training is that it goes beyond simply acquiring data skills and requires merging with organizational skills such as planning, management, and communication. Thank you for attention.